All right. Hey, y'all doing? All right, everyone got your computer? If you got one of my computers, just make sure you keep it separate if you have one of your own. We're heading to code.org today. So you should be at code.org, unit 4, lesson 6, as it says on the screen. And while you're doing that, I'd like you to think about this quick prompt. A water park will let a visitor on a ride if they are 48 or more inches tall, or they are 14 years old or older. I'd like you to make a quick flow chart on your notebook, on paper, or on a little notepad window. You can just type the formula. Think about what we did yesterday and see if you can figure out what your expression will look like to solve both of those things while I get my attendance. On here today? Have you seen it?
I just saw it.
Oh, I just saw it.
I don't know if you.
Okay, I'm gonna give you about 3 or 4 minutes to keep working on this one. I'll be coming around. So again, think of the two variables, right? We need 2 pieces of information to solve this question. We can get on a ride if you're 48 or more inches tall or 14 years old or older. So first think about what are the 2 pieces of information we need, and then how do we compare them with what we already know. So you should come up with 2 expressions that you connect together. Using those little signs right there. You're close. Type it out so I can see what you're. You can open up a notepad window on your computer if you want to type it out that way. Otherwise, a piece of paper will work. You should be signing into code.org here at the same time. Does Chrome not have a notepad built in? I don't know if it doesn't. Hit the, you can hit the little search button and just type in it's a key. I might have Google Keep on it actually. Yeah, this is where we're going to start. Now go ahead and try to do this one first. Anyone need a piece of paper? Nope.
Thank you.
Sure. Need a piece of paper? Take another minute or 2 and then we'll talk through this.
Mister, can I get some paper?
You need paper? Who said that?
Me.
David? There you go.
Oh my God.
Perfect. Perfect.
See?
Okay, let's talk about this. So this is kind of a quick callback to yesterday. So we've got a situation, right? We need to evaluate these situations to determine if the condition is true or false. A water park will let a visitor on a ride if they're 48 or more inches tall, or they're 14 years old or older. So what pieces of information do we need to be able to figure out if we can get on the ride? How many inches, which is called height, right? We need to know the height, and what else do we need to know? Age, right. So we need to know the height, and we need to know the age. Now, what has to be true about the height?
48 or 48.
48 or more. So how would you say that using your comparison operators? Height must be greater than or equal to what? 48, right. Height has to be greater than or equal to 48. So that's one of our expressions, right? That's the first one. So that has to be true, or this other one has to be true. So how would we express this one? How old, which is called age, right? So age has to be what?
Greater than or equal to 14.
Greater than or equal to 14. Perfect. Make sense? So we've got two expressions, right? Height has to be greater than or equal to 48, and age has to be greater, or age has to be greater than or equal to 14. So we need both of these expressions to be present, but how many of them have to be true if it's or? Just one, right? Because as long as one of the expressions is true, then the whole case is true. So what logical operator would we use if either one could be true? To connect these two expressions together, which logical operator would we use if it's or? These things right here, remember we use these symbols to connect two expressions together? Which one do we use if it's this or this? Anyone remember? What's this one? Yeah, the middle one, right? What's this one? And. If they both have to be true, it's and. This one is, the exclamation mark is? Not, right? And so this one is? Or, right. So that's how we hook them together. Height would be greater than or equal to 48, or with the two lines, age would be greater than or equal to 14. So that's going to be our Boolean expression. Does anyone remember the two cases that a Boolean can be? What can a Boolean be? True or false, right? True or false. Okay, so that's just kind of a quick review of what the Boolean expressions can do for us. It helps us decide whether something's true or false. But now we're going to look at how we can actually use that to do something in our program. We've already talked about the condition of when before. Do you remember when you might have used when earlier in the year? What did we do where you set a condition of when something happens? You can look at the slide. Remember when we wrote our own apps? How did we determine when something would happen? By clicking a button, usually, right? Without a conditional operator like if, usually all we've got is when. So it was usually when a user clicks a button, or when a user mouses over something, right? So that would only let us take action if the user did something. I should say when the user did something. But Boolean expressions, if we can evaluate true or false, now we can do something if something is true. So this decides if something is true or if something is false. We can decide what pieces of code to run. So we're going to dig into some applications today. We're going to dig into some code and look at how that actually works. We'll have a chance to kind of explore it, and the next time we'll really get to use some debugging and some programming with it. So I got a short video here, it's just a minute and a half. Take a look at this. She's going to explain what if does, and then we'll actually get into looking at some code.
Our daily lives are filled with decisions, big around us is constantly changing, so we want to adapt the choices we make to match the changing conditions. What's true for humans is also true for computer programs. We don't want our programs to always run in the same way. They should respond to changing conditions. In the last video, we learned how to use Boolean expressions to establish whether something is true or false. We can now add something called a conditional statement to help guide the computer's decisions based on that information. The simplest conditional statement is an if statement. It says that if something is true, the computer should run a specific block of code. Let's say that you want to create a program that displays whether or not you are old enough to see a PG-13 movie. So the question we want the computer to evaluate is, if age is greater than or equal to 13. The question, or Boolean expression, goes next to the if. The block of code we want to run, only if the condition is true, goes inside the if statement. So in our example, whenever the expression age greater than or equal to 13 is true, the program will write to the screen that you are old enough to see a PG-13 movie.
Okay. So that's a really basic explanation of how the if statement would work. Does anyone have any questions on this as we just looked at this? What's happening in that blue chunk of code there? Anybody? What's that blue piece of code doing?
If something's true, then like. It shows them.
If something's true, it'll do the code right there. Anybody agree with that? If something's true, it does the code inside. Give me a thumbs up if you agree with that. Sound good? Anybody not agree? Okay. That's really the basics of how this works. You can see they declare the variable at the start. Age is 15, right? Then it says if age is greater than or equal to 13, it does that code inside. So that's the essential component of how an if statement will work. If a condition is true, it does the code inside. It's just like when the button is clicked, do the code, except this time it's just if a condition is true. So we're gonna dig into some code. We're gonna take a look at how this actually works in a real app. So you're already on code.org. Unit 4, lesson 6 is where we're at. Level 1 is the video we just watched. I want you to go to level 2. This might work better if we were all in some kind of partner. So if possible, Alina and Deja, if you would mind working together, and Josue and Jose, if you could work together. I want you to, first of all, we're gonna play the game, because we wanna see how it works. So level 2 is a little game. And you guys, I mean, you're already in group, so run the game. First thing we should always do is run the game. Play with it a little bit, just explore it, look at the rules, see what happens as you play with it. Just try the game. After you've taken about 5 minutes to play the game, you're gonna go ahead and look at the code. So I'll tell you a little bit more about that in about 5 minutes. So I'll set a 5-minute timer, play with the game, see what you notice. How does it work? What's happening when you do stuff? What do you notice about the app? Make some observations for 5 minutes, and then we'll take a look at the code. Any questions on that? You just want to move over here. You know where we're at?
The lemon squeeze. Yeah.
So play the game, see how it works. It's not a very fun game, but it is a game. It's a complete video game.
Is this the one where you touch the lemon but don't touch the lime?
Correct. But you just gave them one of the observations.
Crap, my bad. Sorry.
No, it's on the front.
Way to ruin it, Duncan.
It's on the rules screen. If you read the rules, you can see them. Make some observations as you're doing this. What do you notice? It does have sound, as you can tell. sound if you want.
And I'm gonna call this for it.
I think my high score is about 45 or so. It's the highest I've seen.
Okay. But
Once you've been through the game once or twice, I want you to take a look at the code. So if you're in a group, you can split this up. One of you can take a look, you can see it's broken into 3 sections of code up here on the screen. Section 1's 1 through 13, 16 through 30, 33 through 53. So split up in your group and each look at a chunk of code for a minute or two, see if you can figure out how it works. And then I want you to discuss it with each other. See if you're on the same page. Remember, you can hide your instructions. You can click that little up arrow so you can see all the code. Which chunks are y'all looking at? Oh, yeah, sorry. I wrote your calendar. I think the highest score I saw someone get was like 45 or so. 24. Of course, that's without cheating and hacking the code to change the rules. Which you totally do right now. You figure out how to do it. You gonna do it legally? If you're into playing around with the code, play around with the code. You can set how many live you start with. You can set how much points you get for each lemon.
I already passed the high score. I got 100.
100. You just change your starting score?
No. I just pressed on 100 once.
Oh, 100 points per lemon.
Yep.
So again, look through the code and discuss it with your partners. What are you noticing about how each one of these sections works?
okay, well, I deserve to. Oh, let me try. Oh, huh.
High school 100.
2,700.
2,700? Okay, so I got 3 groups here. In just a couple minutes, I'm going to ask someone from each group to explain one of the sections of code. So I want you to pick a section of code. Deja and Alita, can I have you look at 1 through 13? This group right here, I'm going to give you the last chunk, 33 through 53. And Josue and Jose, could you all look at 16 through 30? Take a couple minutes, look through these chunks of code. I want you to figure out what it's doing. And in 2 or 3 minutes, I'm going to have everybody just share out what this code is. Touch screen, huh? You know what
I
section?
said this, you know.
16 through 30. 16 through 30. 33 through 53 up here. Just make sure you look through that and see how it's working. And then 1 through 13 over here, all right?
See where you think I'm going? I didn't even miss you.
Uh-huh.
Were you able to work and figure out the code first? Okay.
Daiker.
Let's take one more minute and then just get ready to talk a little bit about what your chunk of code does. You got any questions, Dave? Any questions over here, guys? Oh, yeah. How you did it. Okay, let's talk about it. Okay, Deja, would you mind, tell us what does code 1 through 13 do? What's this first part of the code do?
Basically sets it up.
Basically sets it up, right? Anybody agree with that? It's basically just set up. Did anyone look at this part of the code?
Yeah.
What's it doing specifically? Can you give me any specifics?
Like,
What's it doing to set
it's
it up?
making the score and the lives, and then it's creating a play button so that you can click it.
Yeah, right on. It's setting the initial score and lives, right? The first thing it's doing is creating variables to keep track of score and lives. It's setting their starting values. What triggers all this code? Yeah, if the play button is clicked, when you click play, it sets your score to 0. It sets your lives to 3. It sets a label up so you can see what your score and your lives are on the screen. It plays a sound, and it sets the screen to be the game screen, right? Now, if you wanted to mess around with this a little bit, some of you have already figured out, you can give yourself more lives to start the game, so you can change the value of lives. You can start with a higher score, but basically this initializes the game for any new player. That's good. Jose and then Josue, what does the next chunk do? 16 through 30.
It says, whenever you move your mouse over the, it updates the score, and it updates it by 1, then it changes the location of the lemon and the line.
Right.
It also updates the text at the bottom.
Perfect. Jose, Josue, does that sound like about what you came up with? What makes this happen?
The honest, with, moving your mouse over the.
Right, what do you have, Josue, what do you have to put your mouse over to make this code work? The lemon, right. Because we got on the event that the lemon is moused over, it does all this code. I think that's right on. Yep. Iterates the score, changes the positions, updates the score and the lives on the screen. Okay? Let me scroll down and then, with this group up front, can you explain the last chunk of code here, 32 through 53?
Whenever you mess over the line, it affects your lives, so it decreases by 1 every time you mouse over the line. And then the line keeps on moving in different locations. It updates your screen text. It ends the games when you're out of it.
Right. This code is almost exactly the same. Yeah, that's great. Did anybody notice anything else in here? Makes sense? Sound good? This code is almost exactly identical to the lemon code, except it's for the line. And whenever you touch a line, it takes a life away instead of putting your score up by 1. It also changes the positions, it updates your score and lives on the screen. This is our new thing right here, which let me scroll down so you can see that. This is the new thing that we really need to pay attention to. This is our if. This is our if statement. And I've already updated mine to be less than 1. I think yours started off as less than 0. But if your lives are less than 1, what's it do? Lines 49 through 51. If your lives are less than
It
1,
ends the game.
it ends the game. And how does it end the game? What does it do specifically?
It says
Sets the screen to the start screen and
it changes to start the game.
yeah, shows you how many points you got, right? So this is a complete video game. This is the thing we couldn't do before, which is to make the game end if something happens. We've never been able to do that with what we've been able to do before. So now it's complete. This is like a real video game. It's got score, it's got lives, you can lose the lives, the game ends when you run out of lives, tells you how many points you got, you can click a button to play again. Again, not a very complicated video game, but it's a complete game. So, what if we want the computer program to do something if the if statement is not true? That's when we get to the else statement. So we're going to take a look at the else real quick. Very short video.
Of course, some people will not be old enough. In these kinds of situations, we will want our programs to do something else when the condition is false. In order to do this, we will want to expand our if statements to include an else statement. The commands contained in this else statement only run if the Boolean condition in the if statement is false. In AppLab, you can add an else statement by either dragging out the if-else block or by clicking the plus symbol in the bottom right corner of the if block.
That's literally all there is to it. The only difference here is we've added a condition for what will happen if the if is not true, so if it's false. So, we're going to move on to level 4, and this time, you're going to play the lemon game again, but something is different. There's something that's a little bit different. So, I want you to play it, see what's different, and then see if you can find in the code where that's happening. So let's take 5 minutes for that. You can do this in your group or on your own. Play the game, see what's different, and then see if you can find the code that's making that happen. Level 4, we should all be on level 4. Something's different. It's not a big difference, but there is a difference. What's different? Did you find it? No. If you're not sure what's different, you could always start with the code. See if you can look through the code and maybe you can see something in the code that's new. Not exactly the same, there's a small difference, which you might not see until you lose the game or win the game. Well, lose the game because you can't win.
All it tells you, if you connect the even or odd,
Yeah, can you say that louder?
I knew it.
What is it?
It
Say again?
tells you if you collected an odd or an even number of lemons.
Right. It tells you if you collected an odd or an even number of lemons at the end of the game. That's the new thing. It's not a big thing, but it is a new thing. So where in the code is it doing that? Did anyone find it? At the end, right? You can see it right here on my screen. Line 55 to 59. It's exactly the same code as last time, but we've added an if-else statement onto the end of it. So this uses an interesting thing called the mod operator. You don't need to worry about that too much, but it is on the AP test, so that's why it's on there. We won't use it very often, but what it's doing here is it's saying if the score divided by 2 has a remainder of 0, if that's true, you got an even number. But else, so if it's not true, you got an odd number. Does that make sense? So if you got a score of 16, the remainder of 16 divided by 2 is?
16, 8, yeah.
No, the remainder. 16 divided by 2, what's the remainder? 0, there is no remainder. Because you can divide 16 by 2 easily, right? So if the remainder is 0, we know it's even. But if you have like 17 divided by 2, what's your remainder? You said 1? 1, right? Because 2 goes into 17 8 times and you got 1 left over. So because it's not 0, else, we know the number is odd. So that's how that's working. Okay. There's a little bit of math. That one is more mathy than it'll usually get, but that's how it's working, right? If it's true, do the text that's right there. Otherwise, else, do the other thing. So far, so good? Everybody still with me? Okay. We're going to look at one more example. We're going to skip over the last one because it's not that important, but pay real close attention to this next one because this is really where it all comes together. This is your if-else. Or if-else, else-if.
Sometimes the decisions you will want your program to make have more than 2 possible outcomes. Let's continue our movie rating example, where we want to check whether the highest rating you can go see alone is an R-rated movie, a PG-13 movie, or just a G-rated movie. To check between these 3 different cases, we can add an else-if statement. An else-if statement is another condition that a program checks only if the previous if statements were false. So if age is greater than or equal to 17, write that user can see an R-rated movie alone. Else if the age is greater than or equal to 13, write that the user can see a PG-13 movie alone. Else, write that the user can see a G-rated movie alone. The else condition becomes the default condition, because when all the previous if and else if statements are false, it will default to the else statement. Be careful as you construct longer sequences of else if statements. If you mix up the order, you might not get the behavior you intended. In our example, imagine we had switched the code so that the first condition checked if the user was old enough to see PG-13 movies, like this. This would mean that everyone who is 13 or older would be told they can only see PG-13 movies, even the adults. And with the next else if line, the computer would be looking for people 17 or older in the remaining group. This code misses the adults because they were true in that first condition. This won't work. The computer checks the conditions from top to bottom, so it is important to enter the most specific condition first.
Okay, so a good example for this is, I think, has anyone ever played Mario Kart before?
Yeah.
You ever played that game, Mario Kart? So you probably know in Mario Kart, if you've ever played this, whenever one player gets really far ahead, the people in the back start moving faster, and they start getting better items. So like if someone is way out in front, the people in the back start getting like the blue shell, you get the bullet where you can zoom forward really fast. This is all based on else-if statements. So you can imagine it kind of goes down the list. If player 1 is 10 miles ahead, the people in the back have a 50% chance to get better items. Else if the player in the front is 9 miles ahead, the people in the back have a 40% chance better. Else if the people in the front are 8 miles ahead. So it kind of works. What's up?
Stop, don't come here and interrupt the please. Mr. Daiker, did any of you students bring back your form that Mr. Daiker gave y'all yesterday for the parent to sign? Nobody. Please bring this form back tomorrow, please. Okay?
Well, they only have to bring it back if they don't want to participate, right?
No, they need to bring it back. sending,
Oh, that's not what I thought.
yeah, no, they have to bring it back. Cause it does say they do not, so they need to bring it back.
Oh,
if they
we have to bring it back, but they don't have to sign it.
They do have to sign it.
Do not sign if you want to try to participate.
Right, so this says I do not, so there.
If they don't want to participate.
Yeah.
But if they
So
do
they-
want to participate.
Right,
they don't.
so that means if they don't bring one back,
Yeah.
the assumption is that they want them to participate
Right.
and the student will participate.
Right.
So, okay?
Okay.
Thank you.
Okay, sorry about that. Here, I didn't give you this here. Okay, sorry about that. So the main thing to consider here is just that you wanna always get the most specific first. So if you have a big group of stuff and you're taking little parts of it out, you wanna always start with the most specific condition, because the computer works from top to bottom. So let's take a look at level 6, this is gonna be the last one we really have time for, and then we'll move to the exit ticket. The game has changed again. So play the game, see what's different, and then look in the code to see if you can find the else if statements that are controlling the new behavior of the game. You gotta hurry, I got too much.
They got smaller.
Well, you know, yesterday you went to the bathroom and you never came back. So make sure you come back.
I did come back.
Well,
Yes.
you left your computer open and left it right there? At the end of the day. Well, maybe I just didn't see it. Or maybe you snuck it. Did y'all find the code that's changing it, or you see what's different this time? It's getting smaller?
Yeah. Every time,
You
okay, so.
get to 10.
Look in the code, see if you can find what the reasons are that it gets smaller.
Maybe it will.
Y'all figure it out? Level 6, what's happening? It's getting smaller. When's it getting smaller? At 10, that's one of the times it gets smaller. It gets smaller another time too. Take a look through the code and see if you can find it. Okay, let me challenge you then. Write another one so that it gets even smaller after 15.
21.
Figure this out. I might challenge you with the same thing. Write another, increase the number of else statements, so you have another one, and make it so when it's over 15, it gets even smaller. If you wanna challenge yourself on this, I just told a couple people, once you find the else if statements that control this, see if you can write
Good afternoon.
another else if statement.
All boys and girls basketball players, please.
See if you can write another else if statement that makes it get even smaller after 15 points. Anyone in here play boys or girls basketball? Maybe you switch it back to the text, actually.
Please.
When you go to show text, you can copy. I've already did. You don't have to spend too long trying to do it if you want, but just make sure you give yourself 5 minutes to do the exit ticket. It's level 9. You can keep playing with this if you want. Just make sure you do the exit ticket level 9 before the class is over. Up on the screen, I have modified my program so it gets harder every 5 points. The lemon gets smaller and the lime gets bigger.
No, mister, you got 20 left.
Well, that's because I had to change my code, otherwise I wouldn't live long enough to test it.
That hitbox. You saw it, what the heck?
Yeah, some of it's not impossible because the hitboxes are overlapping, but you can see how you can really mess with the rules by changing your conditionals. I make the lemon get bigger, I make the lemon get smaller, and I make the lime get bigger.
That's my character, and that's the Fix this movie over
Level 9 is your exit ticket. Make sure you check out level 9 before you go submit an exit ticket. Sorry, I didn't mean to call you out like that. I just wanted to see you.
Wait, fix it?
No.
Okay. Yeah, you're in the right place. Just keep in mind what they said. You want to always start with the most specific in what you're doing now. So if you were going to do greater than 15, you just want to make sure you started with that and almost went down.
Trust me. Trust me.
Most specific case. So the most specific case would be like the equation that it's checking against. So like if the score is greater than 10, it would be checked before if the score is greater than 5.
Tómale,
Yeah, I had to give myself like 30 minutes.
Bro, no. Se te va a tirar.
Huh?
Mr. Daiker said.
Huh?
Oh, nothing. I'm on the phone.
Oh, you're talking to someone. Did you do your exit ticket already?
Yeah, I'm doing it.
Okay. You got any questions? You got questions? Okay, so like on my code here, we always start with the most specific thing, or the highest thing. If the score is greater than 20, do this. Then if it's 15, do this. Then if it's 10, do this. Then if it's over 5, do this. Why would we start with the most specific case?
I'm in school too.
If you want to review this, you can view the level 5 video she talks about. If you're stuck on the exit ticket, the level 5 video explains this concept a little bit.
Looks good from here.
You say favorite teacher.
But you understand, yeah, you gotta start with 15 and work your way down. You got your Mari's over there. I never wanna see that thing again. It froze my computer one other, I told you, remember when I was having you working on my, that froze my computer once. I was so dumb enough to use it again. Tempted fate. If I never see that again, that's fine. Whenever you finish your exit ticket, if it's my computer, just put it back up in the rack. We'll get way into debugging and writing our own code for this stuff. So you'll have a lot of chances to play around. Thank you very much for your attention today.
Pero de aquí, estoy viendo el
That is cute. Let me see. Why do I have the number on it? I don't know. I don't even know. Who is number?
She should've put, ten number on.
She should put 10 on it. That's right. Everybody got 10 votes. It's cute.
Thank you.
As long as you have a bill, really involved with it. You gonna let it come on? Yeah. Me too. Bro, that's so cute. Who am I other stuff? Oh, I don't remember. Listen, I didn't know. We should go down here. Yeah, go to practice. I'm not going to practice. Are you not? Oh, yeah, I forgot.
It's to room 14, 2 to room 4, if I have any on here.
Whew.
Did you get it figured out?
Yeah.
Yeah. The example is right up here, so if you look at something like that, you're in the right spot. And of course, we can use the same code, but to just adjust the size of the line and make it bigger, that's not what I have. I'm not sure why the bell didn't ring, but. Oh, maybe it's because the class goes till 3:59. Well, it's over. Why are you here? I got everybody's computer.
Good afternoon, everyone. Will all bus riders on Route 8, 9, and 10, you are released. All bus riders on Route 8, 9, and 10, you are released.
Bus riders, we'll see you.
Deja Bill, you are released. Deja Bill, you are released.
Oh,
See you, David.
March on right, you are released. March on right, Agent Holder, Agent Holder, you are released.
Well, how did it go?
I got interrupted a few times.